Hello everyone, here are your notes. We're going to be jumping into section 6.7 today, which is performing similarity transformations. So in chapter 4, you should remember we did 3 different transformations. We specifically focused on translations, which is just shifting a triangle in different locations, right? We did rotations and we looked at reflections. So those transformations kept the shape congruent. But now we're in chapter 6 where we're talking about similarity. So there is one similarity transformation that does occur, and that's a dilation. And we did a little bit of investigation with dilations. So remember, if you think about dilating, your eyes dilate. So if I were to turn off the lights, your pupils would get larger, right? And if I would turn them on, they would constrict and get smaller. So they're saying similar in proportion, in size and shape, or not in size and shape, but the size is changing. So that's a dilation. So a dilation is a transformation that stretches or shrinks a figure to create a similar figure. Your scale factor of a dilation is the ratio of a side length of the image to the corresponding side length of the original figure. So we've already talked about scale factors, so this should really just kind of be a review of what a scale factor is. So let's go ahead and complete a dilation. So here we're asked to sketch quadrilateral ABCD inside the coordinate plane. So if I have a vertice at 2, 4, so that means I'm going to go, or sorry, 2, 1, I'm going to go to the right 2, up 1, which would put point A right here. B is at 4, 1, so that looks like it's going to be right there. C is at 4, negative 1, and D is at 1, negative 1. Almost a rectangle, but not quite. So now I'm going to connect my dots. It looks like we have a trapezoid there. And we're going to dilate it by a scale factor of 2. Now let's think about this. If my scale factor is 2, should it get larger or smaller? Yeah, it's definitely going to get larger, right? So how much larger? Well, what we're going to do is we're going to take our ordered pairs. So we have A's ordered pair is 2, 1, and we're going to multiply all those coordinates by 2. So the image, remember this right here means the image of A would be at 4, 2, because 2 times 2 is 4, 2 times 1 is 2. I'm going to do the same thing for point B. Point B is at 4, 1. If I multiply everything in there by 2, then the image of B would be at 8, 2. C is at 1, negative 1. If I multiply everything there, then its image would be at 2, negative 2. And then D is at 1, negative 1. So if I doubled everything there, the image of D would be at 2, hold on, I messed up. So this is what I get for not being zoomed out. C was at, not 1, negative 1. C was at 4, negative 1. So that would be at 8, negative 2. Okay, there we go, fixed. And then D would be at 2, negative 2. So now when I go to plot those points, I'm going to do it in a different color because I can make it fancy. 4, 2 is right here. So there's my image of my A. B is at 8, so 4, 5, 6, 7, 8. C is at 8, negative 2. And then D is at 2, negative 2. So then when I go connect those, I'm going to have a trapezoid that is double the size. And my center of dilation is at the origin. Just to keep our lives easier, we're going to keep dilating it from the origin, so you don't have to worry about making that into effect. Okay. All right, so we just did a dilation. So the things that we should be concerned about, if your dilation, so if your K, remember if your K is greater than 1, we know that it's going to be an enlargement. So you might want to jot this down. I know that you probably have some space in your notes somewhere. If your K is some fraction between 1 and 0, so a half, a quarter, then it's going to be a reduction, meaning it's going to get smaller. So if I had an ordered pair, I'm just going to make another quick example here. Again, I would add this onto the back of your notes since you probably have space. If I had the ordered pair A at 4, negative 3, and my scale factor was 4, then what would the image of A be? Well, it's going to be an enlargement, right? And my new point A would be 4 times 4, which is 16, 3 times 4, which is negative 12. Well, negative 3 times 4 is negative 12, right? So that would be your image of A, and it would be an enlargement. If my K was 1/4, then it would be a reduction, right? And my image of A would be, well, 1/4 of 4, or 4 divided by 4 is 1. 1/4 of negative 3 is just negative 3/4, and that would be your new ordered pair. Okay, so if your scale factor is larger than 1, we know that we're going to get an enlargement. If your scale factor is between 0 and 1, so some type of fraction, then it's going to be reduction. What if my scale factor was 5/2? What is that number? So if K was equal to 5/2, is that greater than 1 or less than 1? That's greater than 1, right? Because isn't that the same as 2.5? So that's definitely going to be an enlargement. What would my A turn into? Well, 4 times 5/2. Remember, we can reduce on the diagonals. 2 goes to a 1, 4 goes to a 2. So that'd be equal to 10. If I did the same thing with 3, so negative 3 times 5/2, there's nothing I can reduce on the diagonal, so multiply straight across. Negative 3 times 5 is negative 15. 1 times 2 is 2, so it would be comma negative 15/2, which is approximately, well, it is. It's negative 7.5, right? Okay, so there you have it. There are your dilation notes.